a little bit of these graphing linear equations in our slope-intercept form packet, so hopefully this is good review. Let's take a second and watch that video. So remember, just like you're getting into ALEKS, you can get into your reveal section. It has lots of helps, but of course you have to want to have help to get it, right? Noah, Lucas, put your phones away, guys. So reveal math is the other side of things. I know you're used to going into ALEKS, but you can go into reveal, table of contents here. We are in system 4.6. So we hit 4, click 6, and then it gives us all these options here. I think this is. All right, are you ready? You've seen me teach this. We'll see how they teach it.
You can graph an equation in the form y equals mx plus b by using the slope and the y-intercept.
Alan.
Use the slope-intercept form of the equation to identify the slope and y-intercept. The slope is 2/3 and the y-intercept is 1. Graph the point containing the y-intercept on the y-axis. In this case, graph the point 0, 1. Then use the slope to move from the y-intercept to a second point on the line. The slope 2/3 indicates a rise of 2 and a run of 3. So from the y-intercept, go up 2 units and right 3 units. Another point on the line is 3, 3. Finally, draw a line through the 2 points.
All right, pretty straightforward, right? So that is what they did here. They graphed the y-intercept of 1. Then they used the slope. Remember, 2/3 up 2 over 3. And they got the second point. They used that to draw a line. Remember, that's not a line segment. Lines go infinitely in both directions. So that's why we use those arrows there. All right, let's look at this first example. Gonna have to fix my camera. So identify the slope and the y-intercept. The slope of the line is that coefficient, right? -2/3. And the y-intercept is 4. So we have to start with plotting the y-intercept at 4. We start at 0 and we count up. 1, 2, 3, 4, right on the y-axis, right? Now notice we're going to write this slope as -2 over 3. So from the y-intercept, we're going to move down 2 units. So we're going to go 1, 2, and right 3 units. 1, 2, 3. Once we have that second point at 3, 2, we're going to draw a line. So you can use your planner, you can use another piece of paper, but the goal is to draw as straight line as possible. We're on page 237. If you don't have your workbook, there are packets right up there of 4.6. So that's what your line should look like. All right, think about why we rewrite it with, we have to assign the negative to the top or the bottom so that we know we're either going down and right or up and left, because it is a negative slope. Nice negative. All right. Try this check on page 238. Start by plotting your y-intercept, right? And think about your slope. Think about your slope as a fraction. Remember, this is your rise over your run. So start by plotting your y-intercept and try and go from there. Or do you need to move or can you please have that one? All right, so did you plot your y-intercept? It's at 5, so we would count up 1, 2, 3, 4, 5. And our slope is negative, so we're gonna go down 4. 1, 2, 3, 4, and right 1. You could continue on and go down 4, 1, 2, 3, 4, and right 1. So you should have that straight line. I'm just going to use my reinforced packet here. Remember, your arrows go in both directions. It's not a line segment, it's a line. All right, here's our second example. This is kind of taking it from words. So we're adding it on to what we learned last lesson in 4-5. A typical leopard gecko is 3 inches long at birth. This is like an initial value, right? Or a constant. This is B. And grows at a rate of, guys, enough talking. A rate. Here is your rate. Remember, our slope is our rate. So there's our slope. So from these words, they write the equation y equals m, 1/3 x, plus b, which is 3. Then they're using the slope of 1/3 and the y-intercept of 3 to graph the equation. So we start at the y-intercept. We're right here is our y-axis, right? So right at 3. And we're going to go up 1 over 3. Up 1 over 3. So every 3 weeks, it's growing about an inch. That's what that means. 1 inch every 3 weeks. So we have this nice, wasn't a very straight line. Sorry, I should have used my packet again. So it looks like they're going to still continue to give us an equation, which helps us a lot, right? Jaden has written 6 pages of his novel. This is our starting point. He plans to write 4 pages per week. That's a rate. So they've written it out for you. We know our starting point is 6, so we're plotting that on our y-axis at 6. And we have to think about 4 as a fraction. Any whole number we would put over 1. So we would go up 4, 1, 2, 3, 4, over 1. And it's growing that way. Oh, what did I do? It probably should be right here, huh? There's 1 week. They went by half a weeks on us. This is a half. This is 1 1/2. That's silly. Sorry, I screwed up my graph. I think once you get used to horizontal lines, you'll like them. Since our slope is 0, right? This line, this is 0 fun. 0 times anything is 0, so we're just left with B. Whatever our y-intercept is, that is our horizontal line. So the equation of a horizontal line can be written as y equals B, where B is the value of the y coordinates. So if you're thinking, all right, where does y equal 3? I could put 2 points anywhere along that line and draw the line. So a bit of practice here. If we're graphing y equals -1, well, y equals -1 right here. y equals -1 over here or right here. It doesn't matter. Remember, all we need are 2 points to draw a line. So this is the line y equals -1. These should be even easier than your intercept form lines. Try this. Graph y equals -6. Where does y equal -6? Pick a couple points that y equals -6 and draw a line through those 2 points. This is y equals -1, y equals -6 would be down a bit, right? 1, 2, 3, 4, 5, 6 below 0. So any 2 points on where y is -6 gives us our line y equals -6. So now that we know horizontal lines look like y equals b, when we're looking at vertical lines, we're going to end up with x equals a number. We are going to call it a. So this line right here is everywhere that x equals -2. So as we're graphing these lines, these are undefined, right? They're falling off a cliff. This is everywhere that x equals 4. So look along your x value and find 4. 1, 2, 3, 4. So x equals 4 here, and x equals 4 anywhere here, right? So this is everywhere x equals 4. So vertical lines are just x equal a number, and horizontal lines are y equals a number. So try that quick check there on 242, x equals 7. So follow on your x-axis to 7. 1, 2, 3, 4, 5, 6, 7. And then anywhere else that x equals 7, and it's a nice vertical line. All right, so that leads us to a few quick practice problems. This is page 245. You got lots of time to do numbers 1 through 6. Remember to think of your slope as your rise over your run and start at your y-intercept. So start at your y-intercept, -1, -2, -3, and then your rise over your run. It's really annoying that they're using half things here. Sorry. I don't know why they did that to you. All right, so try these. Remember what these graphs look like. Where does y equal -3? That is 0 fun. And where does x equal 2? That is undefined, right? All right, lots of time. Make sure you're getting those done. And if you get done with that and want to get a head start, we're going to be working on that 4-6 reinforced. That was part of the 4-5-4-6 reinforced packet we started last week.